Peter Haddock, and I'm here with Jason at the Alligator River Bridge Project. You're survey manager here, Jason. Outside, there is a lot of stuff happening. There's piles going everywhere. There's technology being used to deliver it all from Leica Geosystems. But this is a really important project. The bridge it's replacing is really coming to the end of its life, isn't it? We have to move on and get this bridge up as fast as possible. And speed is of the essence, isn't it?
Correct, sir. It very much is.
So tell me, what are we doing? Because this is a 3D modeled bridge project. Where does that come in with the role that you've got?
Well, with the survey manager in a situation like this, you're managing the people, you're managing the models, you're building the models, and so we got guys that are doing that, and they go out and we put them out in the field, and then the Leica equipment takes over from there, and they use those models to be able to expedite the actual pile driving and the other operations that we're doing as we're moving forward, trying to get this project done as quick as possible.
And what's really interesting about that, folks, is the fact that you were saying to me earlier, you've had a lot of experience on bridge projects, but this is fast, isn't it?
Yes,
Faster
sir.
than you
Yes,
ever
sir.
experienced. Explain to me, why that's happened and how it's kind of blown you away.
Well, with this 3D modeling and the way that you can get out ahead of things with this software and the user interface with the guys on the barges, it's not as survey intensive as it used to be. It used to be you had to have a guy, he would be out there and he would have to shoot the barge in and get the barge in position, and then he would have to get the piles in position, and then you could start driving the pile. This kind of streamlines the whole process down to where everything's on your tablet, and as they're coming in, they're watching their tablet, they're bringing the barge in and positioning it. It's a real-time situation that they've got going on there. So with that real-time situation, it allows them to cut down the amount of time that it takes to get from one place to another. So it allows the production to be picked up because of just simply real-time and just following that, and then getting the piles in place, and being able to get to driving faster, and the more piles we drive, the faster it goes. And I saw the old school way of doing it many years ago, and over my 20+ years career, and just watching this out here, it's been crazy to see.
Yeah, it certainly is. And folks, obviously it's a bridge project, and so that means we're going over water.
Yes.
So we've got barges galore. There's actually 3 piling rigs out there as well. But you're explaining to me that we've got different scenarios here. We've got 2 different pile types going in, haven't we? And that is also really tricky to do, isn't it? Tell me, what is the difference between the 2, and why is that been developed for the project?
Well, you had the 36-inch square, so it's 3 foot by 3 foot piles, and then the 54-inch cylinder piles that go out in the middle. The bigger piles in the middle are so they don't have to have as many piles, but they have their own. They each have their own little quirks about how they go in, and all the things that go into getting them into the correct place.
And so when we physically get there, and we're going to go and see this, folks, get out on the barge, because our life vests are going to go on. When we actually see what happens, obviously you said, and I couldn't believe this, you're moving the barge in with 3D machine control. That's great. You get the right position. Then the really, really accurate bit happens, isn't it?
Yep.
When you're moving that piling rig into the right position. And the tablet we see behind me now is the one that the team are using to do that, isn't it? Yep. Tell me what happens physically in that context.
So they have they have the models on their screen, and It has a heading, which way the barge is pointing, it has an overlay to show where this is where all the different piles go in that certain bent. So it gives them something to shoot for as they're coming in. So it's a visual representation of where they're going. Because like you said, we're out in the water. So out in the water, there's, you're looking around, all you see is the existing bridges there, and there's nothing else.
Yeah.
So you're just kind of shooting in the dark out there.
Yeah.
So, but with that visual representation of what you're doing, it makes things easier. So you don't have as many barge moves. You
Right.
know, you can cut down on the number of barge moves you have. You can cut down on the number of, you know, because everything's done with anchors out here. So you know, the old school way, you'd bring it in, you get close, they'd have to drop some anchors and say, okay, yeah, we're pretty close now, we got to move. So then you had to move again. So, but with this system, you don't have to do that. You can see that, okay, I'm within a certain distance of where I'm supposed to be.
Yep.
And by being able to do that, that means you only have to string your anchors out one time. And that's the most one of the more time consuming parts of the process is the anchors that they use to hold the barge in place.
So we've got the anchors in, and that's brilliant to hear, because like that movement, it takes more time and more time and more time. So we've got the anchors in. We now physically go to getting the pile ready, and obviously you've got a precast partner in there. So the pile's ready to go, but that itself then has to have that fine adjustment, doesn't it?
Yep.
Before it goes in. Again, the process of doing that, I've never seen it done before, folks. So what is the process of actually doing that bit and getting that absolutely in the right place?
Yeah. Well, as you stand the pile up, you put it in the leads, and they get it plumbed up and they get everything ready. So then you're ready to start doing the fine tuning at that point. At that point, you're using the anchor lines themselves.
All right.
To be able to position that barge in the correct spot.
Yep.
You know, there's little tricks here and there, the other things they may do, but for the most part, that's what they're using is the anchor lines to get things pulled into place and making sure that you have good tension so that as you go to drive the pile, it doesn't move on you.
Yeah.
You know,
yeah.
Because that's the last thing you want is because once you put it in the mud, you drop that pile down. It goes a certain distance. You're not moving it anymore.
Exactly. It's not coming back out.
It's not coming back out. It's not going left to right, up to down. It's not moving anywhere. But until you get to that point, you can actually shift a little bit. So it's the keeping that good tension on those lines and doing the things that you need to do.
And that's still all done by the tablet now.
All of it's done by the tablet. It's real time. It's a real time situation. Again, it's the same situation as you had coming in.
Yeah.
So you know, you're not changing anything. You're still looking at everything right there on the screen.
So we've got that scenario. We're now going into piling mode, as you say. A little bit of a challenge again on this project, isn't there? Because we haven't got, like, you know, you'd hope for a rock base to go, right, bang, we've hit in solid here. This sort of area, Alligator River, folks, National Park next door, is muddy. And then there's not as a rock base. So how do you figure out, after you've done your test piles, how do you figure it out how big the piles need to be?
Well, that's where the engineers come in.
Yeah.
And, you know, they use the pile driving analysis, PDA.
Yeah.
They use their blows per foot. And that's when all of that information comes together to give you what distance you need to be down. So here we pretty much are driving to refusal, which is a certain number of blows per foot.
Right.
So that's how all that works.
So as I understand it, folks, I'm talking to you earlier, it get to a certain level, and if it takes a certain amount of hits or a certain amount of time to go any further, that is strong enough.
Yes.
to keep that in. And that's really important, folks. So then, you know, so we've also got a real problem here, and there's a river, and the river is used by fish and other animals. We're in a natural reserve here, but you've got a limited amount of time right now before you have to stop because the fish are spawning.
Right.
Tell me what that is and what that's all about, and how the technology is helping you really race ahead.
Yeah. Well, because of the moratorium that we have, it's coming up here on the 15th of July.
Yeah.
And from the 15th of July till October 1st, we can't drive anywhere in the river because the fish are going to be spawning at that point in time. So the big push on this job has been, hey, we know we have a limited amount of time. We know we're going to be missing a couple months of the year that we can't do anything. So we need to be able to go drive as many pile as fast as we possibly can. And so this is we spoke with Leica and we came up with this system, and they were our partners in all of this, and we put this system on there, and it's been flying. I mean, I've been doing this for 20 plus years, and this is the fastest I've seen pile go in the river.
And that sort of partnership with Leica has not just been about them giving you kit, has it? It's about them, using the Connex connectivity system as well. It's the also all in the cloud as well, isn't it? This project, which is great because you can have people from all over the country looking at that data, looking at that information, and even sharing it with the client as well.
Correct, correct. And the other part of it too is, especially with a job like this, whenever you people don't look at it from this perspective, but when the guys go out on the barges in the mornings, it's a feat to get back on land.
Right.
It's not as simple as hop in your truck and drive over to the office.
Yeah, yeah.
So having the Connex connectivity has really helped out with that. They can upload, we can upload from here, and they can pull it in on their end. We can they can upload and we can pull it in on our end. Like you said, with the conversations with Leica, they can log in, they can see what's going on, they can help troubleshoot things if there's problems that are happening, and that whole teamwork aspect of it has really been great.
It's fantastic. So what's really cool is we're here in America. It's a different style bridge altogether, and we're using the technology to drive it forward. But what it's replacing is a really old bridge, and it has a swing out section, and 20 minutes at least for people to have to wait in traffic. What are we getting when this project actually finishes, and how will that make a big difference to the people that live in this area?
Well, you won't have to deal with the swing bridge anymore, so that'll be completely gone. But it's also when we have hurricanes in this area that
Oh,
come
right.
through. So this is a main evacuation route on the hurricanes.
Right.
So it's public safety is going to be improved because of this. To being able to move people in and out faster and easier is going to be one of the things that's going to be upgraded. And like you said, you can't get caught by the swing bridge anymore. So that's going to be a wonderful thing. And it allows the boat traffic to move freely because, we have to wait, but they have to wait too. So it's kind of everybody's having to wait on everybody. So once this bridge is done, the waiting's over.
Fantastic. And so the waiting's over for us, folks, because we need to get out there and onto the barges and see it for real life. What a fantastic project this is. And it's great to see the collaboration of the team and how we can use technology to make sure that everyone's working to the right model in the right way, and that we can see a 20-year career going, hey, we're just blitzing it here. Great to see you. Fantastic. Cheers.
Thank you for your time.